Good morning. So our topic for this morning is diode approximation. There are three approximation for the diode. The first approximation, or sometimes known as the ideal approximation, followed by the second approximation and the third approximation. So for the first approximation, we see the diode, okay, either an open switch or a closed switch. So what does it mean? So meaning to say, if we bias the diode, such as we apply here a negative terminal of the supply voltage and this positive is connected to the cathode. Now this type of biasing is what is known as the reverse bias. What the biasing will do with the diode is it will simply open the diode, so it will look like an open switch. Okay, so with an open switch, what happens is we don't have a current. Okay, so the current that passes through the diode is simply equals to 0 because you apply a reverse voltage, and that's the reason why what we have now here is a flat line under the reverse voltage. Then obviously, if we have also a tester here, say for instance we have an analog tester, and we would want to test the voltage across the diode. Okay, I'll place here the positive. Probe, and I'll place now the negative probe at this side. So the reading will be equal to the source voltage, which is the reverse bias voltage, and that's the reason why you have here a value for the reverse bias. You don't have a value for the current because we treat the diode as an open because it is under the reverse bias, and applying a tester across the diode will simply read the supply voltage, which is the applied negative supply voltage. So that is for the reverse bias. We see the diode as an open switch. Next, let's have now the forward bias. So how do we deal with the forward bias? So for the forward bias, as you remember last time, forward biasing simply means the anode side is connected with the positive terminal of the supply voltage, while the cathode side is connected with the negative terminal. So the anode is connected with the positive and the cathode is connected with the negative. So having this one, you are now forward biasing now the diode. So we have the forward bias. So under the ideal approximation and using the forward bias, we see the diode as a closed switch. So like this one, we see the diode as a closed switch. So with the closed switch simply means there is now a flow of current within the circuit. Okay? There's the flow of current. And then, if you are going to get also an analog tester, and you would want to measure the voltage across. Now you would want to measure the voltage across the diode. So let me put here the probes of your tester. The first probe, the positive, and this is the ground. So this is the positive and the negative. What you are going to measure now is the 0 volts, or the voltage across is short, which is 0. So for that reason, under the forward bias or quadrant 1, what we have now here is a 0 volt. Okay, 0 volt, but then there is an increase, or there is a value for the current across the diode because we have a closed switch. So that is under the ideal approximation. Now let's proceed now with this problem. It says here, use the ideal diode to calculate the load voltage, or VL, and the load current, or known as I sub F. Alright, so here is our circuit. The supply voltage is 10 volts, and the positive terminal is connected with the anode, while the negative is connected in series with the load, which is 1 kilo ohm, and in series with the ground. Now this is the symbol for a ground, and this is also a ground. If this terminal is connected to the ground and the end of the 1 kilo ohms connected to the ground, then we can draw the circuit. Okay, so this one is also connected to this. So you can draw the circuit like this, in this manner. The resistor can be directly, it can be directly now connected with the supply voltage. There you go. Okay, so what is required? The load voltage. Now, since this is ideal and this is 1 kilo ohm, so it is obvious that the anode is connected with the positive. So this is now treated as a closed switch. If it is a closed switch, the resistor is directly connected with the supply voltage. It is across, it is in parallel. Therefore, the voltage across our load is simply equal to 10 volts. Or, there you go. Next, and since this is a closed switch, it is understood that there will be a flow of current, okay, within the circuit. And using Ohm's law, we have current is simply equal to voltage divided by resistance. So, what is the voltage across our load? That is 10 volts. And our resistance is simply 1 kilo ohms, thereby giving us now a value for our load current, which is 10 milliampere. So this is an example under ideal diode where we treat now our diode as either closed or open. For this manner, we treat it as a closed switch since it is the anode side is connected with the positive side, and the cathode side is simply connected with the ground, and the ground is connected with the negative terminal. Now, if in case the diode connection looks like this, then there will be a different treatment. So if in case the diode looks like this, the cathode is connected to the positive and the anode is much nearer to the ground. Okay? So the treatment will be different. Okay? So this is cathode and that is positive. And this is anode connected to the ground, and the ground is connected to the negative terminal. Therefore, at this scenario, what we have now is a reverse bias. Okay? So under the reverse bias, we treat now the diode as a open switch. Okay? So if it is open, what we have now is that our current here, so our current that flows here, okay, the current is simply equal to 0. Why? Because there is an open. Why is there an open? Because the diode is in reverse bias. So if there is no current that flows through the circuit, therefore we said that voltage is simply equal to current times resistance. So the voltage across your load would be simply equal to 0 current multiplied with the resistance of 1 kilo ohms. Or the voltage of the load will simply equal to 0 volts. What about the current of the load? Same goes, so the current of your load is simply equal to 0. Okay? 0. Why? Because there is no current that passes throughout the circuit. So that is how you can treat a diode under the ideal approximation. If it is reverse bias, then we treat the diode as an open switch. If the diode is forward bias, we treat the diode as a closed switch under the ideal approximation.